Hello class, for today's lecture, we will have your very first topic in clinical chemistry, the introduction, the basic principles and practices. A few reminders before we start. Number one, please take down notes. For my students, a soft copy of this PowerPoint has been shared to you in our OneDrive. Listen attentively, avoid unnecessary distraction, and give extra attention to information marked with a star. All information marked with a star is a recall question in the board exam. Here are our learning objectives for today. Okay, so first and foremost, what is a goal of a clinical laboratory? As medical technologists, we are a part of this whole healthcare system. But what is the goal of the clinical laboratory in the first place? Number one, facilitate the correct performance of analytic procedures that yield accurate and precise information. Second is one of the very important reasons is to aid the patient diagnosis and even their treatments. As the medical technologist, we are the one po na nagpapaprocess ng ating mga specimens and testing it so that we can aid our clinicians for their diagnosis and even monitor their treatment kung gumagaling na po ba sila. And then third po is the correct use of basic supplies and equipment, more on for the medical technologist who will handle the specimens and then possess an understanding of the fundamental concepts critical to an analytic procedure. So for the introduction, we will be introducing units of measurement. Here in the clinical chemistry laboratory, it is considered one of the most automated areas of the lab, meaning we are using here more on for machines. So pag nagtitest po tayo here in ClinChem, more on machines na po talaga ang ginagamit natin. It's very rare na meron po tayong mga manual. And with the machines, there is this measurement po of the different analytes that we are testing. So for the units of measurement, sabi po dito, any meaningful quantitative laboratory result consists of two components. The first component represents the actual value, wherein ito po yung actual na concentration, and then the other one is the second or the label identifying the units of expression. It's very important po here in our measurements na meron po tayong unit so that we can define the physical quantity of that particular unit of numeric value. Like, is it on the basis of mass, length, time, or even volume? A good example of this is 50 milligram. So in 50 milligram, here we have two components. The first component is the actual value, which is 50, and then yung unit of measurement natin, which is milligram. Milligram po, we know that this is a physical quantity for mass. Meaning, kung ganito ang given natin, we are checking for the mass of the analyte or the substance. So under the units of measurement, we have the SI or the System Internationality Unites. It is a preferred scientific literature and clinical laboratories, and it is the only system employed in most countries. Commonly, we have two, the SI system and then the metric system. However, in some countries, they are only using SI. So the SI system units, or commonly referred to as SI units, are based on the metric system, and several subclassifications exist within the SI system, one of which is the basic unit. And then under this po, itong table natin sa baba, these are the basic units of SI. So let's know what are the different physical quantities or dimension, their unit name, and their abbreviation. For mass po, for mass under the SI, ang kanyang unit name is kilogram. Again, mass, kilogram, mass, kilogram. For length naman po, length po is commonly referred in meters. Again, length is meter. For time naman po, time po is seconds, time, seconds. For temperature, commonly Kelvin. Again, for temperature, commonly Kelvin. Although here in the Philippines, no, ang madalas na ginagamit natin is in Celsius. But according to the SI system, the unit name is Kelvin. Next po natin here, we have electric current. Electric current is ampere. Again, electric current, ampere. For the amount of substance, that's mole. Again, amount of substance, mole. For luminous intensity, it is candela. Again, luminous intensity, candela. So again, here are the basic units plus their unit name and their abbreviation. Kindly memorize po this table. So as mentioned, our SI system has several subclassifications. The first one is basic, which is yun po yung first 7 nga, yung length, mass, time, electric current, temperature, amount of substance, and luminous intensity. Again, these are the base quantities or basic units. Then under the basic units, we have the derived. In its name, it is derived. Derived units po are derived from the basic quantities or base quantities. So under derived, good example, we have frequency, which is in hertz, force, which is commonly referred to in Newton, Celsius temperature or degrees Celsius, and the catalytic activity is in Catal units. So again, these are the derived. Again, in the term derived, in the way, it is derived from the basic quantity or base quantities. And then additional subclassification that exists within the SI system is the accepted non-SI. So pag sinabi po nating accepted non-SI, the following po are actually not under the SI system. However, since lagi po silang ginagamit, they are commonly used, they are already accepted in the subclassification. So good example of this is minutes, hours, and days. Commonly, ginagamit po natin yan. Even liters, di ba? Liters po ang isa sa pinakamadalas na ginagamit natin when it comes sa volume. And even angstrom. So again, these are the subclassifications in the SI system: basic, derived, and accepted non-SI. So the SI uses standard prefixes that when added to a given unit can indicate a decimal fraction of multiples of that unit. So let's proceed here in the next slide. So here are the common prefixes used within the SI system. So dito po tayo mag-i-start sa base unit. Again, this is the base unit. Ano nga po ulit class ang ating base unit ng length? So dun sa ating previous slide, it was mentioned that the base unit of length, for example, is meter. So pag nandun po tayo sa base unit ng SI, for example nga is meter, it means 1 with an order of magnitude of 10 raised to 0. Again, if we are under the base unit, like for example nga, ang base unit po ng ating length is in meters. So, ang meaning po ng ating base unit, again, it is equivalent to 1 plus, ang order of magnitude is 10 raised to 0. Next po, kabisaduhin naman natin yung ating mga 10 raised to 1 hanggang 10 raised to 9. So, that is deka, hekto, kilo, mega, giga. Again, that's deka, hekto, kilo, mega, giga. Again, that's deka, hekto, kilo, mega, giga. And then to memorize this po, the order of magnitude will be like this. 10 raised to 1, 10 raised to 2, 10 raised to 3, then multiples of 3 na. From 3, 10 raised to 6, and then 10 raised to 9, and so on. By 3s na po. Again po, here is how we will memorize po yung ating degree or order of magnitude na 1, 2, 3, 6, and 9. Deka, hekto, kilo, mega, giga. So what does this mean or what does this pertain to? So for example, we have decameter. For decameter, this is 10 raised to 1. So from 1, magkakaroon tayo ng decimal point here. Since 10 raised to 1, we will move the decimal point 1 place to our right side. So this will now mean 10. And then same thing goes with the others po, like our hekto. For hekto naman, 10 raised to 2. So in this case, meron pong dalawang movement. So from the base unit of 1, so lagay tayo ng point. Move tayo ng 2 decimal places kasi 10 raised to 2. This will become hectometer is equivalent to 100. And then same thing goes po with our kilometer. Kilometer naman po is in the order of magnitude 10 raised to 3. So lagay ka ng point sa 1 and then you move the decimal places 3 times to the right. So ang kilometer is equivalent to 1,000 meter. And then same thing goes with the mega as well as the giga. So again, deka, hekto, kilo, mega, giga, 1, 2, 3, multiples of 3 na next, 3, 6, and 9. Next, doon naman po tayo sa mga negative naman. Again, the base unit here is meter for the length. Again, that means 10 raised to 0. Doon naman tayo sa may mga negative like decimeter. Decimeter po, ang order of magnitude is 10 raised to negative 1. So from there, kung ito ang 1, magmo-move naman tayo from the decimal point here to the left naman po kasi negative. Okay? So with that, ang magiging itsura niyan, 0.1. And then how about centi? Centi naman po is 10 raised to negative 2. So negative 2, you move 2 decimal places, 1, 2. It will become 0.01. And then for the millimeter naman, millimeter, it stands for 10 raised to negative 3. So yun, move mo po ng tatlong decimal places, 1, 2, 3, it will become 0.001. Same thing with the micro and nano, ganun lang naman din po. The order of magnitude is negative 6 and negative 9. So these kinds of conversions or for the common prefixes, we will be using this for the laboratory math on later discussions. Okay, next po natin here we have your electronic reporting of results. Electronic transmission of laboratory data has been now popular. Dati po kasi mga manual logging, sumusulat lang tayo ng mga datas natin. But ngayon po, electronic na po lahat. Meron na po tayong mga system for them. And the more routine use of electronic medical record, coding, billing, and other data management system have caused much debate regarding appropriate standards needed in terms of both reporting guidelines and safeguards to ensure the privacy of the data and the records. One of our flagship in a healthcare setting is the confidentiality of result or the privacy of our patient. So since readily available na po yung ating mga data sa isang system lang at marami pong possible na maka-access sa data na ngayon, doon nagkakaroon ng debate if it is really a good thing na meron tayong mga sariling system for the data records of our patient. But even though meron tayong mga debates like that, mas marami pa rin pong pros ang paggagamit ng electronic transmission because mas madali po nating ma-retrieve ngayon yung ating mga information na needed as well as mas madali po siyang i-access or they are more accessible. So good examples of databases that uses their own coding system for laboratory observation. We have logical observation identifiers, names, and codes. And then ito po yung isa sa mga pinakakilala, the IFCC and IUPAC, International Federation of Clinical Chem and International Union of Pure and Applied Chemistry. We also have the ASTM, HL7, SNOMED-RT, the Systematized Nomenclature of Medicine Reference Technology. So these are again databases that use their own coding system for laboratory observation. And speaking of reporting of results, while no uniform standard exists, there is an agreement that in most systems, the test name that is conducted to the patient, it should be clearly identified in the laboratory results form and should have its unique code as well as they should indicate the value and the unit or the appropriate abbreviation. So, bigay tayo ng example ng isang laboratory result form. Again, kailangan daw po ang criteria. Each test name should be clearly identified. Kung anong test ang ginawa, dapat nakalagay doon sa lab result. As well as kung quantitative to, kailangan ng value plus yung unit of measurement natin. Sige po, bigay tayo ng example. So in this example, this is under hematology section. They have performed here complete blood count. So here in the complete blood count, it was stated kung ano po yung test na ginawa, which is yun nga po, CBC. And then, minention pa dito na nag-test daw ng hemoglobin, hematocrit, RBC, WBC count. So, tama tayo doon sa unang criteria na dapat naka-indicate ang test name. Aside from that, minention din po doon na kailangan daw po naka-indicate yung value na nakuha. In this case po, for example, hemoglobin po ang sabi, they had gotten 132 na value and yung unit of measurement is in grams per liter. Ayan. So again, na-meet niya yung tatlong criteria, yung test name, yung value, plus yung unit of measurement. Minention po siya dito sa ating lab result form. And then, aside from those, the reference ranges naman for most clinical chemistry are not universal and in those instances needed to be included for proper interpretation. Yung reference ranges naman po or the normal values for each testing, it should also be clearly indicated because again, the reference ranges sometimes are not universal. There can be a slight variation of reference range from one laboratory to another. So, pwedeng medyo may konting pagkakaiba silang dalawa. So, para malaman po ng ating mga provider or doctors na ito ang reference range ng laboratory na ito, dapat nakalagay po siya sa lab result form. In this form naman po na laboratory result, dito po sa CBC na ito, aside from the results itself, pati po yung reference ranges ng lab is properly indicated. Again, this should be properly identified and indicated because reference ranges sometimes are not universal or there can be a slight variation from one laboratory po to another. And then, once the specimen has been processed, delivered to the correct department, and tested within a laboratory, a lab report or lab result is generated to transmit the test results back to our healthcare provider or doctor. At ito nga po yung ating good example ng lab result form at alamin natin ngayon yung mga important parts ng ating lab result form. Ano yung mga expected na makita natin doon? Number 1 po, the logo or the facility kung saan po ginawa ang lab test, they should have their own identifier. Dapat nakikita natin kung sinong lab ang gumawa. Good reference number for additional identifier of either the patient po or the test requested, like sample ID. And the next po natin, of course, very important, yung ating mga patient's information like complete name, age and date of birth, and then minsan pati po yung gender, it should be clearly indicated. The requesting physician or the requesting doctor, pag may nakalagay po na requesting doctor doon sa ating lab request, dapat po ilagay po natin sila dito sa lab result as well. And then very important, of course, yung ating mga dates like when is this test requested? When was it processed? When is the data or the result was released? It's very important po yung mga dates natin kasi may certain validity dates lang po ang ating mga lab result form. Hindi po ibig sabihin na kapag nagpa-test ka ngayon ng CBC, valid pa ang CBC next year. Because again, there's a certain time na po na nag-lapse. So it's very important na yung dates po properly indicated. And then aside from that, lagyan po natin ng star ito pong dalawang mga signature for the lab result form. The lab result form po has the name and signature dapat po ng una, RMT with their PRC license number, and then the name and signature of the pathologist or the head of the laboratory with their own PRC license number. Again, itong dalawang signature po na ito, this is very important po ha sa lab result form. This lab result form will not be valid not unless this two person has their signature in the lab result form. In the board exam po, one good recall question here is, sino po or pwede daw po ba ang medical technician na mag-sign sa official lab result? The answer po again is no. Again, medical technicians yung hindi pa po RMT, kakagraduate pa lang ng medtech or hindi pa nagtitake ng board exam or nagtake po and hanggang med technician po yung nakuha po nilang score. Again, a medical technician is not allowed to sign official lab results. Only RMT and the pathologist, both of them po, should have their clear sign or signature po here in the lab result form. Okay po? Sige po, proceed tayo sa next slide. So for the next slide, pasok po tayo sa mga reagents. So again, as I've mentioned, clinical chemistry lab is one of the most automated areas of the laboratory. So we are using here different kinds of instruments and machine. And most instrument manufacturers also make their own reagents. So kumbaga, kung sino ang gumawa ng machine, commonly sila din po ang nagdi-distribute ng mga reagents para sa machine na yon. Usually, it is readily available in a kit form. So, nasa isang box na sila, sama-sama na po doon lahat ng reagents na kailangan. Some of the reagents will require the addition of water, like kailangan i-reconstitute sa distilled water or even a buffer to the pre-packaged reagent components if ever needed lang naman. Minsan naman kasi ang mga reagents, pwede mo na siyang diretsong ilagay sa machine, no need for the addition of water or a buffer. So what are the different kinds of chemicals used for reagent preparation? We have analytical reagent grade. This is used for quantitative and qualitative analysis, meets or exceeds the established standards of American Chemical Society. So, meron pong standards ang paggagawa ng analytical reagent grade. Aside from that, chemicals of this category are suitable for use in most analytic laboratory procedures. So, pwede nating lagyan ng check ang analytical reagent grade na pwede po siyang gamitin in the clinical laboratory. And then, aside from the analytical reagent grade, we also have ultra-pure reagent. For the ultra-pure naman po, this is put through additional purification pa. Kaya siya naging ultra-pure na talaga. So, additional purification steps for use in specific or special testing like chromatography, atomic absorption, even the immunoassays or for the test kits, and then the other na mga special na test. So, dahil po dun sa additional na purification niya, very pure ito, si ultra-pure, pwede rin po itong gamitin sa lab. Next po natin, chemically pure or pure grade. Do not be deceived by the term pure grade because chemically pure or pure grade po has impurity limitations that are not stated and that preparation of these chemicals are not uniform. Basically class, wala pong standards. They are not recommended to be used in the clinical laboratory. Because again, wala pong standards or specifications kung paano pong ginagawa or pine-prepare ang mga reagents na ito. So, pwede ito siguro more on for demonstration lang, like para lang makita kung paano yung ginagawa yung procedure. But if you will be using this for actual testing ng patient sample, this is not advisable again because the preparation is not standard or not uniform. Okay, so that's the first three. Next tayo, we also have the fourth one, which is the USP and NF. This is commonly used to manufacture drugs. May or may not be used in clinical laboratory because the purity standards of this USP and NF are not based on the needs of the laboratory. Although, na-establish nyo na po na hindi siya injurious to humans, kasi nga po sa drugs po yan ginagamit. However, iba naman po kasi yung para sa in vivo or sa inside the body, tsaka po yung mga kailangan ng laboratory machines nyo. So, they have their own needs. So, ang ating mga USP and NF, yes, again, they are non-injurious, they are safe. However, yung kaniyang purity po is not on the base of the needs of the lab po. And then, fifth one po, we have the technical or commercial grade, only used for manufacturing and again, never to be used in the clinical laboratory. So, yan po ang ating mga chemicals used for reagent preparation. And then, the other than the purity aspects of the chemicals, yun nga po yung mga grading na binigay natin kanina, the laws related to occupational safety and health administration or the OSHA requires manufacturers to cleanly indicate the following. Dapat daw po nakalagay ito doon sa bottle or di naman kaya sa label ng ating chemical. Kailangan daw po indicated ang lot number as well as any physical or biological health hazard and any precautions needed for the safe use and the storage of any chemical. So for example nga dito po sa picture, ayan meron tayo ditong mga hazard symbols. Kung baga, kailangan naka-indicate and madaling makita na merong hazard ang chemical na ito. And any manufacturer or a manufacturer is required to provide technical data sheets for each chemical manufactured on a document called MSDS or Material Safety Data Sheet. Speaking of the MSDS, this is a document that contains information on the potential hazards and how to work safely with the chemical product. It is an essential starting point for the development of a complete health and safety program of the laboratory. This also contains information on the use, paano gamitin, paano i-store, how to handle, and even emergency procedures all related to the hazards of that chemical. MSDS are prepared by the supplier or the manufacturer of the material. Commonly class, pag bibili po tayo ng mga chemicals, yung supplier na po or manufacturer ang magbibigay ng documents na ito. It is intended to tell what hazards of the products are, how to use the product safely, what to expect, if the recommendations are not followed, what to do if accidents occur. Kunwari like natapon. So, kailangan naka-indicate po sa MSDS kung ano ang gagawin. And then, how to recognize symptoms if you are overexposed to the chemical and what to do if such incidents occur. So, lahat po yan, lahat ng information regarding sa chemical, pangalan niya, mga pagkukuhanan, as well as hazard, dapat po nasa MSDS. Kindly take note though that currently, hindi na po ginagamit ng iba yung term na MSDS. Currently po, SDS na lang po yung name niya. Nawala po yung term na material. But basically, they serve the same purpose po. So again, what info is found in MSDS? Product information like yung pangalan, manufacturer, suppliers, addresses po kung saan siya pwedeng makuha, as well as emergency phone numbers nga in case po na magkaroon ng accidents. Even the hazardous ingredients, may lead ba, may mercury, lahat ng hazardous po kailangan naka-indicate. The physical data, is it a solid, liquid, gas? Different kinds of hazard like fire, reactivity, toxicological properties, health effects like is this carcinogenic, nakakakos ba siya ng cancer, preventive measure, first aid measures, as well as preparation info like who is responsible for the preparation and date of preparation ng ating MSDS. So here is a good example of an MSDS or SDS of the chemical hydrogen sulfide. As you can see, it was indicated here yung identification niya, pangalan, chemical name, other means of identification, product use, as well as yung supplier's details and emergency telephone numbers in case po ng mga accidents. And then yung hazards din, very important nga po na ma-indicate po siya sa MSDS. Para po yung gagamit ng chemical is well aware kung ano pong klase ng hazard ang pwede niyang makuha sa chemical na ito. So as I've mentioned, MSDS is now currently known as SDS. So the purpose of both the MSDS and the SDS remains unchanged. It is still to list the information as well as to say what kind of hazard this chemical may do to you. But the major difference lang po between the two is the standardized formatting. Ang MSDS po kasi, ang format niya doon sa papel can be very random. Like, pwedeng mauna yung hazard bago yung identifiers niya. However, here in the SDS po, meron na po siyang fina-follow na format. So, all SDS follows the GHS 16 section formatting, while MSDS po could come again in many different formats depending on the organization. So, speaking of the 16 sections that is being followed by the SDS, again, this is the standardized formatting. So, ito po yung tamang pagkakasunod-sunod daw ng format. Yan po ang fina-follow ng ating mga SDS. So, number 1, yun nga po yung identification. Second is hazard identification. Third is composition, info on ingredients, and first aid measures. And here are the others pa po. So, for number 12 to 15, these are just non-mandatory like ecological information, environmental hazards, disposal consideration, the transport and regulatory information, as well as additional information including the date of the preparation or the last revision of that SDS. So yan po yung 16 sections ng SDS po natin. Okay, so move tayo to another topic, our reference materials. Still, these are reagents or chemicals. So under the reference materials, we have your primary standards. These are highly accurate and directly traceable to an internationally recognized standard. They have been extensively characterized and validated using well-established and precise measurement techniques. Primary standards are used to establish the initial calibration of laboratory instruments and to create secondary standards for routine use. Like, for example, meron tayong bagong acquire na machine, bagong bili. So sa unang bukas or unang calibration, pwede nyo pong gamitin ang primary standard. So that is the initial calibration. Examples of primary standards include the SRMs or the Standard Reference Materials from organizations like the NIST or the National Institute of Standards and Technology. And then, since meron tayong primary, yun po yung isa sa pinakamalinis, pinakamaganda, pinaka-okay or pure, highly accurate. Meron din po tayong mga tinatawag na secondary standards that is also known as working standards or working solutions. They are derived from the primary standard, so dun din po siya kinuha and mostly used for routine calibration and QC in clinical laboratory, yung daily QC nyo. So, ang primary kasi, it's more on for the initial calibration, bagong bukas na instrument. But on the routine use, yung halos araw-araw po nating pagko-QC, we can now use the secondary standards. They are prepared to mimic the properties of the primary, but they are not as rigorously characterized. But still, this is okay to be used for daily monitoring of QC and routine calibrations po. So speaking of standards, here are the following solutions for checking accuracy and precision in the laboratory. So we have two, either the standard or the control. The standards po, the primary and then the secondary one, is a material again of known composition that is available in a highly purified form. So pure daw po ito, walang gaanong interferences, walang contaminants. So since they are very pure, the universal color should be colorless. Kasi yung kulay sometimes can cause interferences. So since ito po ay isang standard, yun nga po siyang pinaka-standard, highly purified, it should be colorless. For the control naman, control are materials with physical and chemical properties closely resembling the test specimen and containing a pre-analyzed concentration of the substances being measured. In this naman po, for our controls naman po, controls po again resembles the test specimen. At ano nga ba ang pinaka-common na specimen sa clinical chemistry? Of course, that is your serum. Ayan, ang serum nyo po is color yellow. That's why the universal color of a control, it should also be yellow because yun nga po, they closely resemble your specimen. Dito po sa CC, ang pinakamadalas nyong makukuha is serum. So, ang ating universal color is yellow. Either human-based control or a bovine-based control. So even water here in clinical chemistry or the laboratory in general, meron po tayong mga specifications. So like distilled water po is purified by distillation process, kaya nga distilled. And here we remove almost all organic materials. Next po natin is yung ating deionized water, purified by ion exchange. And then all ions are removed, hence the term deionized. And then the RO water or the reverse osmosis water, this is purified by reverse osmosis, uses pressure to force water only through a semi-permeable membrane. So, meron pa rin from time to time na makakalusot ng mga bacteria at yung mga maliliit na molecules kasi semi-permeable membrane lang po ang reverse osmosis water. Kumbaga, parang pinapadaan lang po siya sa parang filter lang. And then we also have the ultrafiltration and nanofiltration, one of the most sterile ones, removing particulate water. Lahat ng particles, lahat ng microorganism, bacteria, parasites, and any pyrogens and even endotoxins of bacteria. Isa ito sa pinakamalinis, ang ultrafiltration and nanofiltration. And then aside from this, we also have your UV oxidation with sterilization. And with ozone treatment, this can destroy microorganisms or bacteria but may leave behind residual products naman po. So yan po, 'di ba? Pati tubig talaga may specifications po yan sa laboratory. Meron pong mga certain na procedures na meron po silang specific water po na re-require. So for the reagent water categories, we have type 1, 2, and 3. Type 1 po ang masasabi natin sa pinaka-pure, pinaka-malinis, while type 3 po is yung pinaka-hindi malinis. But not necessarily madumi, okay? Hindi lang siya yung pinaka-okay when it comes to their purity. Okay, so for the reagent water categories, type 1, 2, and 3, You can differentiate them according to the following. Number 1, you can check for the maximum colony count or in CFU per ml. Ang maximum colony count po pertains to the number of bacteria. Okay, so again, ang pinaka-malinis nga dito, pinaka-sterile, pinaka-pure is type 1. So, ang ating maximum colony count sa type 1, ang pinaka-konte with less than or equals to 10 CFU per ml only. While for type 2, ito mga so-so, 50-50, siya po yung nasa moderate or gitna. 1,000 CFU per ml ang maximum colony count. While for type 3, it is not specified na. Kasi po, ang type 3 po, again, hindi naman sa madumi, pero hindi siya yung pinaka-pure or sterile. So here, hindi na po natin gaano alam ang maximum colony count nito. It is not specified. Pwedeng 10,000, 50,000, 100,000. So madami na po yon. With regards to the silicate content, this denotes naman po potential contaminants. Again, yung silicate contents, this denotes potential contaminants. Again, ulit-ulit tayo, type 1 ang pinakamalinis. Therefore, the silicate content of type 1, siya po ang pinakakonte with 0.05. While for type 2, 0.1, mas madami ng kaunti. While type 3 po, 1.0 na po ang score ng silicate. When it comes to resistivity in mega OHM, resistivity po, next slide lang ako for the meantime. Resistivity, pure water is devoid of ions and it is a poor conductor. The relationship of resistance and purity is linear. As purity increases, so does resistance. Meaning, mas resistant, mas pure. Again po, mas resistant, mas pure. Again, ang pinaka-pure nga po dito, ulit tayo, type 1. That's why resistivity of type 1 is the highest with a score of 10. Kasi nga po, again, mas resistant, mas pure. So, ang pinakamataas na score natin sa resistivity si type 1 with the score of 10. Type 2 po, 1.0, while type 3 po, 0.1 na lang po. For the pH naman, type 1 and type 2 is not specified, while type 3 po, 5.0 to 8.0. For the types of water used, your type 1 po uses ultra-pure water because nga again, this is the most pure, most sterile. For the type 2 po, deionized water is applicable. While for type 3 po, reverse osmosis water po, yung semi-permeable membrane lang. So yun nga po, may mga dumadaan pa rin dyan, mga bacteria as well as mga maliliit na molecules. So, dun din po nagkakaroon ng koneksyon ng RO water sa colony count niya na hindi na ma-specify kung marami. For the uses naman po, again, the type 1 is the most pure, so you can use this for testing that will require a minimum interference or those tests po na mga sensitive like trace metal, iron, and enzyme analysis. Well, for type 2 naman po, commonly, mga analytical processes, mga routine like reagent preparation and QC materials. While for type 3 po, since nga po medyo maraming contaminants dito, tsaka hindi siya ganun ka-sterile, glassware washing po ang pinaka-purpose ng ating type 3. Okay, so ito pong next slide natin, it is just a summary of the test parameters here in the table. Like yung pH nga natin, the colony count, ang pinaka-konti nga again is ang pinaka-pure, si type 1. Resistivity again, the more resistant, the more pure. Pinaka-pure si type 1, so siya ang pinakamataas na resistivity. Detection of coliforms of bacteria, chemical oxygen demand, as well as different kinds of elements like yung presence nga po ng silicate doon sa ating types 1, 2, and 3 na ang may pinaka-konting contaminant na silicate is si type 1 once again. So with that po, thank you for listening. If you have any more questions or clarifications regarding this matter, you can contact me in this email po.